Hello everyone. Thank you for giving me opportunity to present my paper. My paper is about lean-driven SAP production planning, optimization using machine learning for inventory and throughput efficiency. My name is Mahendra Kumar Khalal. I am a senior SAP analyst working on the company OC Channel. I'm working from Houston, Texas. So first of all, what are my title contents? Basically, I'm gonna talk about the abstracts, introductions, literature review, methodology, result analysis and discussion, conclusion and final scope, and then I listed out my references that I used. So basically, about the abstract, I would say this study is for SAP inspired lean based production planning and optimization model to improve the throughput of efficiency in continuous flow of manufacturing using large data sets. Uh, uh, it's a comprehensive pre-processing pipeline is applied, including data cleaning, Johnson power transformation, advanced feature engineering, and rolling statistics and lag-based variables. Feature selection using select KB based with a mutual information regression reduces the dataset to 100 highly informative predictors. So basically, what this study is all about, like in traditional SAP, right? The way we are planning, it's based on the historical data, and then how machine learning improves the throughput, plan versus actual planning. There are different model, right, that we have, and that are used in this study. There are different model interpretability is ensured using sharp or lime explanations, and then we have a Monte Carlo analysis to confirm the framework or reduce the or risk of the planning, right, for the production planning, SAP based production planning. So so as I said, production planning, it's aligned with the capacity, materials, and the capacity of the machine, materials, and scheduling with the customer demand, and then to improve like a throughput or reduce the lead time, enhance the overall operational performance, right? So that particular model we use for the better planning in the ERP system. So now the traditional planning, it used the historical data which are fixed, and then let's say if you have 1 year data with you or 5 years data with you, which are not, it's a fixed data, but with the way global market are changing each every day or every month or every week, every year, that dynamic planning require, which is not there. So the ERP system, we have like product MRP planning, advanced planning, optimization, supply chain. It's a real time coordination of planning, but without machine learning and capabilities, we have to incorporate the machine learning capabilities in this one to match actual plan versus actual in this case. So which is a lean based production planning to reduce the overproductions, like basically the seven waste, right, that we have in the lean principles to reduce the the waste like overproductions, stockouts, waste, underproductions, right? Different waste type we have in the lean principle, using the lean principles. So I have compared a summary of studies that are based on the inventory optimization and machine learning applications. There are different studies that available that I compare, and then which focus on different algorithm and different um, um, type of the planning or inventory optimizations, the way like XGBoost, we have DSRM, we have YOLO SSD, faster RCNN, we have machine learning based failure analysis with the retaining strategy, we have XGBoost linear regressions. So there are so many methodologies we have that the data set they have differently, like integrated inventory systems, inventory and supply chain forecasting systems, individual failure data sets that they have used. Uh, the performance they with this one they achieved is like inventory turnout improved by 130% for the DSRM, 30% increase in inventory accuracy, 25% reduction in stock outs, 15% reduction in overstocking, which are like lean based, which is a waste, right? And then it's for overstocking for the lean principle, so it's reduce that waste. If you see the predictive analytics with AI and cloud-based technology. So the XGBoost has achieved the highest performance with R square. I square is a percentile. We know that that measures the percentile actual versus plan. And then YOLO 0.89 accuracy with SSD 0.30 recognition time, faster RCNN, linear regressions accuracy with the XGBoost is like 63.66%. So the plan versus actual overall, uh, with all this methodology will improve. It reduce the other waste, I would say, which requires in the lean based environment. So basically the methodology that proposed by me is like, we have data set input, data pre-processing, data splitting. We will split the data, and then feature selection and scaling, and then model implementation and tuning, and evaluation and interpretability. So if you see data input, we're gonna get the data from the ERP systems, like for the manufacturing data, procurement data, finance data, and then we pre-process that. We'll pre-process that one data, and then we'll split them in a 80 to 20, 80% for training data, and then we have testing data for the 20% for the performance evaluations, and then we'll scale up with the select k based, like a Python highest variable, uh, which will apply to features to get the proper features, and then it'll do by like power transformation is followed by like power transformation for feature scaling, and then normalizations will normalize will predict based on the current market, and then finally we'll use the random forest and XGBoost models, which are implemented in the hyperparameter tuning to enhance the predictive performance. So we'll predict based on the random forest, which is a machine learning application, right? Which a methodology, like you have a lot of questions that you answer, and if and buts, and that you answer, and then machine learning will take and then plan accordingly based on that. So we have historical data, you have split the data on the chunks, and then finally you use the power transformation for the select k base to get the variability, and then finally you apply random forest machine learning methodology models to rule out the like with the dynamic planning basically, right? And then finally you use the evaluations to predict the plan versus actual, like R square, MAP, MAE, REMSC, and then Monte Carlo is for the like risk analysis, right? The final risk analysis, and then robust final result basically it will get. So these are the proposed solution framework that I used. Result analysis, if you see it shows that random forest improved the R square from 85 to 16%, and then while XGBoost slightly increased from 83.61 to 83.97 with reduced errors. So figure 2, if you see right here on my right hand side, right, is a random forest predicted versus actual throughput and residual analysis, right? It performs of random without cross validation, where predicted throughput efficiency closely follow the actual values along with the diagonal reference line. So what is saying that whatever we actually predicted, and if you see the actual throughput efficiencies is 70 to 85 closely follow each other, like almost 85%. It's correct, based on the random thing, like plus and minus 4 is the range of the deviation with that. For the XGBoost, the other model that we have, that is resulting in graphic card without cross validation. Left plot compares the predicted versus an actual throughput efficiency, with the most point near a diagonal indicating the high predictive accuracy, right? And the right residual plot shows the error concentrated between -3 to +3, center around 0. So basically it shows -3 to the variation, basically it shows. And the sharp summary, if you see on the right, shows the feature importance analysis. Represents sharp summary plots which shows the contribution of each features to the model output. Features such as OEE proxy squared, quality proxy squared, log process, standard will have the strongest influence in sharp value are more than 1.0. So what are the fluctuation impact model output we have, right? Highest feature value, basically. So now if you see line based local sharp explanation for random forest, for two individual data points generated by metadata enhanced random forest models, it emphasizes the effect of OEE and quality proxy on individual risk predictions, and the transparency and the other two governments through visualization of the feature importance and decision boundaries. Basically it helps us to take the proper decisions, whether variations, what are the different risk involvements, what are the availability of the risk, and then how quality looks like, stability, all that. Stability will increase, quality will improve, risk availability will, we can measure that. So all that things if you can see on the table 3 and table 4, it's for scenario simulation versus Monte Carlo throughput risk. How mean throughput, standard throughput, mean throughput, maximum throughput for the Monte Carlo risk. On the right side, 70.61, 0.42 for standard throughput, 69.63 is a minimum throughput, and maximum throughput is like 72.166. So on average, it's like 70.61 as a mean average. So performance comparison for the lean driven SAP optimization models are like the main two are random forest and XGBoost. As I said, we have SVM linear as well and CatBoost as well. With the random forest with the R square, it has a highest performance, basically 85.91, whereas XGBoost has 83.97. In root mean square error, XGBoost has a 1.49, and then random forest at 1.40, and then mean absolute error we have 1.10 for random forest, and XGBoost has a 1.17. So these are the like SVM has 0.001, and then CatBoost has 0.9656. So basically, random forest and XGBoost are the highest performance model in this case. So final conclusion is like with the SAP automatic reorder point calculations, it enhances the replenishment timing, reduce stockouts, lower carrying cost, and improve operational sustainability, which is a lean based SAP alignment optimization model integrates with the domain driven features, engineering with SML learning to forecast throughput efficiency. Basically, it's saying that it reduces the waste, it improves the efficiencies, on time delivery, all that features processes improves, and then it reduces the cost overall with the tune and random forest performance R square. And then finally this framework supports data driven decision making in SAP environment by combining lean stability metrics with explainable machine learning, right? And then limitation includes synthetic, like we have limitation includes like synthetic target, single data set testing, and no cross validations. Basically, if you don't do if you use the single data set, if you don't do cross validations, that is a limitation. For future work, we'll use the real ERP data, cross validations, and advanced model like LSTM, transformers, auto machine learning, and reinforcement learning. So these are the improvements for our future scope for these studies. These are my references that I took for my case studies. And yeah, thank you again. As I said, my this is my email that you can reach out to me. Uh, Thank you for giving me opportunity to present this paper. Thank you.